Okay, we're back up. About the names. You got a parallel line, then you have a line going across, right?
Yeah.
We said this is something you really need to watch for because that creates all kind of similar triangles and whatever, right? There are all kinds of names involved. This line is called transversal, and well, those two lines we were talking, two angles we were talking about, it's called interior angles, right? And then the angle on the same side is called consecutive angles. You know, these two angles add up together is how many degrees? 180, yes. And then these two angles are called corresponding angles. And this angle are called exterior angles. They're all
outside.
Yeah, they're all yes.
The outer part of the parallel.
Exactly. They're all equal. Also. Okay. Yesterday we were interrupted when we were doing this. But anyway, there's just one step. That when you take a derivative of sine x and log x, let's just say, you don't know how to do it, then you can do each one, right? And of course, if you have three things, let's say u, v, w, right? You take a derivative, right? Then you take each one of them, u, v, w. You take u, you take u, v, you take v, then you take u, v, w, and then take w, right? Same idea. Now you have a cube, right? Yeah, you have a cube. One is u, one is v, then one is w. And then it goes out a little bit. So you just take one at a time, all three sides. Right, same idea. This is what we're talking about. That when you do any of these algebraic things, you need to understand the geometry of it. When you do geometry things, you want to know the algebraic things, because very often you have a geometric problem. The best way to prove it is actually algebraically. And then there are things about vector we didn't cover. A lot of times the geometric problem, if you know the coordinates, the way to solve it is through vector. But we didn't explain things about vector, like vector A, how vector A and B, two vectors, operate on each other. This sort of things. So we're not going to get too deep into that, just enough that we can get through mechanics. That's it. Okay. Last time we were solving a problem like this. Right?
Yeah.
I was wrong when I was doing it. So I'll do it very, very fast, quickly this time, because you know how to solve this now, right? The way to solve this is you want to find a mu ty, right? Right?
Yeah.
And then this equals to mu y prime plus mu prime y, right?
Yeah.
And you take the mu out, or you divide the mu on both sides. This is, you divide mu, this is 1 over mu y equals to, this divide out becomes y prime plus mu prime mu y, right?
Yeah.
This is if you make, right? If you make this side and this side is the same.
Yeah.
Right? And in order to make this, we just, this is log mu equals to you take a derivative. I mean, take integral of p, right? Then mu equals to we're not gonna worry about this. Absolute value equals to c e p dt, right? Yeah. When mu equal to this equals to this. That means I can sub this into this.
Yeah.
Right? So that's 1 over mu y prime equals to g, right?
Yeah.
Multiply the mu over mu y prime equals to mu g, right? So mu y equals to mu g dt, right?
Yeah.
And take an integral on both sides. Now all you need to do is divide mu over. Right? All of them are functions of t. Now I'm clean. This is I have the mu equal to this. I have the g, and you just take an integral on this mu times g. Now this you get the y through this way. Of course, this is kind of messy, but you actually solve this solution. This equation. You know. Okay, now we're gonna do one more of this. You're gonna know the reason for this, but right now I'm just gonna do it. It's okay. Now I'm gonna make another change. When we write this stuff, dy dx, I write y prime, right?
Yeah.
But when I write dy dt, normally it's not right at this. I put a dot on y.
Yeah.
This too, when I do a dot, that's a y against t. Typically it's time. Okay, so okay, a function like this.
Yeah.
The function we just solved is 1 degrees. Now I'm putting up 2 degrees. Can you guess why I need to do 2 degrees?
No.
Is this familiar with you?
Yeah.
Yeah. This is acceleration is position dx, sorry, dx dt. This is what? The change of position in time.
Yeah.
What is this?
X?
No, what is it called? X is called a location, right?
Yeah.
When this location change in time, what's this called?
Velocity?
Yeah, right. Velocity or speed. It's really velocity is a more proper word for this, because velocity is defined as a speed with a direction, right? Now I do this again. What's this?
That's acceleration.
Yeah, this is acceleration. In other words, if you put a force on it, you have an acceleration, and this is the relationship.
Okay.
And this is there are 2 dots on the position. So I need to be able to solve this before we really get on to physics. Okay, now we let's see how we do this. Yeah, the first we're gonna do it is we're gonna forget about this g. You just say y dot y2 dot plus p y plus q equal to 0. We'll try to solve this one.
Mm-hmm.
Okay. We know how to solve. We know how to solve this, or actually, we know how to solve. Right.
Yeah.
What's the solution for this?
It's e to 5x.
Right. E to the power t, whatever. Yes.
Well, yeah.
Yeah. So we want to change this into something like this.
Okay.
The way we do it is we call a u. We make a u equals to y dot.
Okay.
Let's just say I can make this into a u.
U prime.
Yeah, right. I can make this into a if I make u equals to let's see.
And you just make it like the problem we just did.
Not really. What I'm trying to do is make this into u now. One dot came down, one dot disappeared, right?
Yeah.
I'm trying to make this into some kind of a form that gets to this. In other words, if I do this, right, u dot equals to, I have that.
Yeah.
Oh, sorry, there's a y here. This, if you substitute it in, right, this is u one dot, right?
Yeah.
And this could be u, right?
Yeah.
And this is some kind of this has to be y.
Yeah.
If I can make this into a let's see what's the best way to do this. If I can split this up somehow, let me just write this up. Okay, u dot plus something, right? Plus let's say alpha u, right? Plus beta y plus plus qy, right?
Yeah.
I'm gonna alpha plus beta obviously equals to p.
Yeah.
I split up p. If I can split up p like this, right?
Yeah.
I'm gonna take the beta out. U dot plus alpha u. Hey, alpha u. Let's write this again. U dot plus alpha u plus beta y dot plus q beta y equal to 0. Okay, now this is good.
Okay.
Hey, no. You get it? Let me write it again because you need to see this one. Alpha u plus beta
Wait, I saw it.
y dot plus q over beta y. Right?
Yeah.
If this equals to this, these two things become equal.
Yeah.
Right? This becomes, because this is a 2 dot, this becomes a derivative of this. This becomes a derivative of this.
Yeah.
Do you see it? Okay. And that becomes y prime plus beta y equal to 0. Now we're going to solve for this. And then once we solve for this, we can go over it again because this is y dot plus something y equals to something. After we solve it, it'll be y dot plus something y equals to something. This something is the solution for this.
Okay.
And then we can solve it this way. Yeah. So let's do this. Let's see how I want to do it. It doesn't matter. We just do the way we do it. So alpha and beta is stuff that we set up.
Yeah.
It could be anything. So we take a look. Alpha equals to. I don't want to get too much away from this. Alpha equals to Q divided by beta. Right?
Yeah.
Right. And also alpha plus beta equals to P.
Yeah.
Right? This uniquely determines alpha and beta. Right?
Yeah.
Now, you take a look at this. Alpha beta equals to Q. Right? Alpha plus beta equals to P.
Yeah.
Yeah. Does it look familiar? Let's see how we do this. You know what? Probably the best way to do it probably is just yeah, the best way to do it probably just stop here. Okay. Once we do this, this becomes alpha.
Yeah.
Yeah. Okay. Now let's rewrite it this way. U that is y dot plus alpha y. This dot plus this go back to prime because this is easier to write. Plus alpha y plus beta right?
Yeah.
And then this y prime plus alpha y equals to you divide this over, that's this is minus beta, and this is log this is minus beta e to the minus beta dot t, right? Something like that. You move the beta over, right?
Yeah.
Divide this over, this is equals to minus beta. Then you take an integral. This becomes log. This side becomes beta. You just take integral of it. Minus sign comes out.
Yeah.
And then you put it back to this. Now this becomes this form. Right? And then you can solve for this, which is this, right? And therefore it's solved. Following?
Yeah.
Okay. We're not gonna actually go into it. It's just too convoluted. Anyway, as long as you have an idea that this equation can be solved in this general way, it doesn't matter. You can just close your eyes and solve it. You can solve it. Let's look at another way of solving this solution. We're gonna that's another equation. Here. Another way of solving this equation, we're gonna let me see. Yeah. In order for this to be a little bit cleaner, we're gonna write this. We're gonna rewrite this just so it's cleaner, easier for you to look. Like we change the symbol. We change it to A plus B plus C. Okay.
Yeah.
We're gonna assume Y equals to E lambda X. Okay. We're gonna assume it.
Okay.
Because when we solve this, you know, when you solve this, where's the first one? You see, this is, yeah, that, but at least mu is in that form. But anyway, we'll just assume this. Okay. Now, we're gonna actually, let's see. Yeah, let's just do that. You put this in, right?
Mm-hmm.
This derived types, there's two, this becomes A lambda square e to the power of lambda x, right?
Yeah.
This is B lambda e to the, right?
Yeah.
Then we take this e part out, becomes A, right? Does this look familiar? You want to solve for lambda? We don't know,
Okay.
right?
Yeah.
So lambda actually equals to minus b plus minus b squared for AC, right?
Yeah.
Okay. And there are two of them.
Yeah.
Right? We call it 1 and 2, right? 1 is plus, 2 is minus. So y equals to some kind of a combination of C1 e lambda 1t plus C2 e lambda 2t.
Yeah.
Okay? That if A, B, C's are constant, they're not a function of t. Yeah. Okay. Let's see how much time we spent. 23. Okay, let's just make one more comment about the taking integrals. We just come to this uv, you take a prime equals to u, you take a this, right?
Yeah.
This can be used, if I write this out, this is d u v dx equals to d u dx v plus u dv dx, right? duv equals to dv du plus u dv, right?
Yeah.
Now, if you take an integral of this, you find out one thing. That is integral of u dv equals to uv minus v du.
Yeah.
This is a very important trick when you do integral. If you can make this into this way, right? But you don't know how to integrate this, but you know how to do this,
Yeah.
this can change. And maybe this you can process and you can do it again or something. Yeah. That's just the comment. Let's see what other comment I want to make. Oh yeah. dy dx. I was just this is we made this comment a few times already. Fx g. If you have something this form, an equation,
Mm-hmm.
You know how to solve this one?
No.
There's something x, something y.
Um.
How do you solve it? What's the goal of this?
To like find out, like just to keep fx equals to what? Cause
Fx equal to what?
yeah, you just trying to find what fx is.
No. Fx, they tell you. This is the equation written out. You know what fx is, and you know what g is.
Trying to find what y is.
Yeah. But don't you know what y is in this relationship? There's a relationship is in here. When we talk about solving a equation like this, what we're talking about, really? See, this is the equation, right?
Yeah.
We just went about solving it. What are we talking about?
Like we're trying to find what y is without dealing with the differentials.
Right. We want to take the differential out.
Yeah.
We want, first of all, first thing we want to do is take out the differential. After we take out the differential, it's possible that the equation becomes this form, right?
Yeah.
If we can get this into this form, that's fine. That's great. But if we cannot, at least this doesn't have any differential in it. So first goal when you look at a function is to take out the differential.
Yeah.
So how do you take out the differential in general?
You just integrate it.
Right. Yeah, you integrate it. So how do you integrate this? How do you integrate this thing? I don't have the earliest paper. What's the strategy of this? Can you hand me that stack of papers? Yeah. What's the goal of? I mean, when you see something like that, how do you do it?
I try to take like gy out, like separate from fx.
Oh, okay. How do you do it? What do you do?
You divide gy over.
Yeah. Right. Okay. That's good. Divide gy over, right?
Yeah.
Okay. So that'll be dy dx. That'll be 1 over g. Right?
Yeah.
What else?
Then you integrate both sides, and then this
How do you
turn
integrate?
into like a log or whatever.
How do you integrate both sides? There's still x on this side. You know, when you integrate, it's always this fx dx, this form. You can integrate this. You can integrate a fx dx, always. This becomes a fx, right? In our way of writing.
Then just multiply dx over.
Yeah, okay. So that becomes 1 over gy dy equals to fx dx. Right? This you can take an integral of it. This becomes a function. This is not a log. You don't know what that is. What about gy is sine y? So it would become the 1 over. Okay, is that
No.
we need to integrate that. Is that 1 over? Yeah, it's not, right?
Yeah,
How
no.
about we make this a homework? You find out what that is. It's not. Okay, let's say this. Sine x, 1 over sine x. Take a derivative. How do you do that? Derivative is always easier.
You just like do the quotient thing, take derivative of 1 and then sine x.
Okay, you show me how to do it.
I don't know. There's like this rule on differentiating a quotient.
Okay. D sine 1 over sine x. Right? You do dx, right? You don't know how to do dx. But you know how to do d sine x. Right?
Yeah.
That's just 1 over sine x, d sine x, right? Then you do d sine x, dx, right? This is minus 1. It becomes minus 2. Right? This becomes minus 1 came out. So sine x minus 2. Right? Really, this, we're treating it as d sine x minus 1, d sine x. If you can't see it, we'll make sine x u. This becomes du minus 1 du. Yeah, this equals to minus 1 come out, u minus 2.
Oh, okay, yeah, I get it.
This is what we're doing here. And sine x dx is what? Cosine x. Right? This equals to minus cosine x sine x squared. Yeah?
Yeah.
You just put something, you can put the intermediate steps. There's a function of a function. You know how to do 1 over x, right? You know how to do sine x. You don't know how to do this stuff together, put together. So you can chain this thing. Yeah? Chaining this, and then also if it's the multiplying, okay, equals to u dv plus v du. Between these two rules, okay, you can du. You don't know how to do this, du dx. You don't know how to do this, you do it du dv dx. Okay, these two rules.
Okay.
You can do a lot of business. But when you do an integral like this, it takes some more thinking. You're asking yourself, what you, in other words, if I want you to take a integral of this, you know how to do it now, right?
Yeah.
It is 1 over sine x. How do you get to it? How do you get from this to 1 over sine x, since you don't know? Now you know, of course, right? But let's say you don't know. Takes more doing. Okay? Actually, for this, it's very easy. You this, if you can see it for this, right? Cosine x minus sine x squared, right? Dx, right? This equals to, if you take a cosine x in, right? You can just take it in. This you know how to do.
Yeah.
Yeah, this is equals to 1 over sine. Because this becomes, if you call this x to the power minus 2. Minus
Yeah.
2 plus 1 becomes minus 1, and then the minus sign go out with the minus sign. So this is actually, when you really sit down and look at this, it's not that hard. But if you just take a quick look at this, it's whoa, how am I going to do this?
Mm-hmm.
Okay, that's how people make up these problems for you. They find a wicked function to start. They take a derivative of it, then give it back to you. They ask you to find the integral. Oh, when you have to find the integral, well, it's simple. Always. All right. Let's see. What else do I want to say? What's the time here? Oh, okay. That's long enough. Okay. We'll see you next time.